right, so this is the practice test for chapter 2. So problem 1 says describe the transformation of f of x is equal to x squared represented by g of x is equal to x minus 3 quantity squared plus 4, then select the correct graph of each function. So once I do that, first thing I suggest that you do is that you go ahead and you look at your vertex. So remember, your vertex is going to be, oops, here, let me use the right thing. It's going to be the opposite of that one. So it's going to be positive 3, and it's going to be the same as that one. So it's going to be 4. So if we look at this, we know that we are going to go 3. Now remember, you're going to go on the opposite way. So we're going to go right, even though it makes sense that negative would go left. And then we're going to go 4. We're going to stay the same. So we're going to go 4 up. So again, what I suggested, ladies and gentlemen, is if you're not sure, you can always graph your function and see which one it looks like. But again, f is our original function. That's what they told us. So let's just see where g would go if we started at the origin. So if we look at the first one there, if we went over, because we know we need to go 3 right, so that would be 1, 2, 3, and 4 up. Well, we don't have anything there, so we know that one's not going to work. Let's see, the next one over, well, that's not going to work either, because that is going down. Let's see, how about this third one? 1, 2, 3, and then 4 up. 1, 2, 3, 4. Yeah, that one will work. So it has to be that one there. Okay. All right, number 2. Graph the correct function of f of x is equal to x squared. Again, that's our parent function. And g of x is equal to negative x plus 3 quantity squared plus 2. So remember, what that is telling us here is that on this one here, we're going to go left 3. This is telling us we're going to go up 2. And then this right here tells us we have a reflection over x. So if we have a reflection over x, we know that it's going to flip over on the x-axis. So we can, right now, get rid of that one because it's not even flipping over. And again, we want to go left 3 and up 2. So if I look at this one here, if I go left 3 and up 2, well, that's not going to work. Let's see, left 3 and up 2, it's not that one. Left 3 and up 2, there's our vertex. So that one is, and then we did flip it over, so it has to be the last one. Again, if you're not sure on this one here where it's just asking you to look at the graph, put it in your calculator. Okay, number 3, let the graph of g be a vertical shrink by a factor of 1/5, followed by a translation 8 units down of the graph of f of x is equal to x squared. Write a rule for g. So as I keep telling you, your book likes to say when we have more than one, they'll start with an h of x. And we know that since it's vertical, we know it's going to be on the outside. So we're going to say it's 1/5 of our function, which is f of x. So that tells us we're going to have 1/5, and our function is x squared. All right. Then they're asking us to go 8 units down. So when we go 8 units down, that's our g of x. And again, we're going to take our previous one, which we called h of x, and 8 units down, that is again on the outside. So now we have our h of x was 1/5 x squared, and then we're going to take our minus 8. Number 4, let the graph of g be of translation 2 units down, followed by a vertical stretch by a factor of g and a reflection So they're saying, since they're saying and there, we could probably do them both at the same time. And a reflection in the x-axis of the graph of f of x is equal to x squared plus 7x. Write a rule for g. Okay, again, I'll start with the h of x. And again, our h of x is going to take our f of x, and we're going to go 2 units down, so it's on the outside. In this case, our f of x was x squared plus 7x. And then we're just attaching that 2 to the outside. Our g of x, all right, and this time here, we're going to do a vertical stretch by a factor of 9 and a reflection. So that tells us we're going to take our h of x, and since we're going to do a vertical stretch, we know it's on the outside, and a reflection in the x-axis is also on the outside. So we can say, since it's on the outside, we can take our negative 9 together, and then we know everything else is x squared plus 7x minus 2. And they will expect you to expand that, so you're going to distribute through the parentheses the negative 9. So when I do that, I'm going to get negative 9x squared. Negative 9 times 7 is negative 63x. And then negative 9 times negative 2 is positive 18. Okay. Number 5 was the one that most of you were having a problem with. All right. But again, we should be able to do it by just finding out, hey, we're going to make our vertex. So our vertex is going to be at negative 6. Again, because it's the opposite. And negative 5 because it's the same. So we go down to, negative 6, negative 5. So I'm going to go over negative 6 first, and then go down 5, and that will be our vertex point. Remember, our axis of symmetry is our x value, so it's going to be negative 6. So again, you guys have this piece of paper, so I would go ahead and even do like I'm doing and show where my axis of symmetry is, and I'll say that x is equal to negative 6. Then what they want us to do is they want us to plug in the point negative 2 and negative 4. All right? So when I do negative 2, when I say f of negative 2, again, wherever I see x, I'm replacing it with negative 2. So I'll have 1/4 negative 2 plus 6 squared minus 5. So we know negative 2 plus 6 is 4. 4 squared is 16 minus 5. 1/4 of 16, or 16 divided by 4, is 4. 4 minus 5 is equal to negative 1. So when x is equal to negative 2, we would go down negative 1 and make our point there. So our point is at negative 2 and negative 1. And then again, as I told you today during class, look at symmetry. So it takes us 1, 2, 3, 4 to get to the axis of symmetry. So we're going to go 4 on the other side, 1, 2, 3, 4, and make our point right there at negative 10 and 1. Okay, we're going to do the same thing now for our, what did they say, negative 4. So we're going to take f of negative 4. And again, I'm going to take 1/4 of negative 4 plus 6 squared minus 5. Negative 4 plus 6 is 2. 2 squared is 4. So I'll have 1/4 of 4 minus 5. Well, 1/4 of 4 is 1, and 1 minus 5 is negative 4. So at negative 4, We're going to go over -4, and then we're going to go down 4, and so our point will be right there. So, and then, and then again by symmetry, it takes us 2 to get to our axis of symmetry, so we go 2 on the other side, and we'll make our point right there. All right, that's all they wanted. You can't draw the graph because they don't allow it. They just have the points up there, so we're done. We're good. All right. For number 6, find the maximum or minimum value of f of x is equal to x squared minus 16x plus 30. So since this one is standard form, we know that we're going to write our x. So we need to get our x coordinate for our vertex. So again, that's going to be negative b over 2a. And when I plug that in, I have that negative, and then I still have that negative 16. And then I'm going to have 2 times 2. Negative 16 times, well, I have 2 negatives there, so that becomes a positive. 16 divided by 4 equals 4. Okay, now that's not our maximum or minimum. Remember, our maximum or minimum is when we take and evaluate it at x is equal to 4. So we're going to say 2 times 4 squared minus 16 times 4 plus 30. 4 squared is 16. 16 times 2 is 32. 16 times 4 is 64. 32 minus 64 is negative 32 plus 30. And that'll equal negative 2. So we know our value is negative 2. Now to remember, if it is a maximum or minimum, we have to look at our a value. All right? If our a value is positive, that means that our parabola is going to open upwards. So that means that our value will be at a minimum. Remember, if it's negative, it'll open downwards and it'll become a maximum. So remember stuff like that. Number 7, identify the x-intercepts, the vertex, and the axis of symmetry of the graph f of x is equal to negative 0.25 x plus 2 times x plus 8. Again, I've been asking you all the time, is this vertex form, intercept form, or standard form? You would tell me on this one here, it is intercept form because there are 2 x-intercepts. They're telling us to identify them. So remember, the easiest way for you to think about it, again, is look at the x-intercepts. It's going to be the opposite sign. Since it's positive 2 there, we know we're going to have negative 2. And since it's positive 8, we know we're going to get negative 8 as my intercepts. All right. To find the vertex, remember, our formula for the vertex, when it's in intercept form, is x is equal to p plus q divided by 2. In this case, it's negative 2 plus a negative 8 divided by 2, which is negative 10 divided by 2, which is negative 5. All right, so that is our vertex. That is our x value of our vertex. And remember, the x value of our vertex is also our axis of symmetry. So we know that that one is going to stay the same there. And then to find our y value, we're going to take our function and we're going to evaluate it at negative 5. So again, it's telling us that x is equal to negative 5. So I have negative 0.25. And then I'm going to take negative 5 plus 2. And then I'm going to take negative 5 plus 8, which will give us negative 0.25 times what? Negative 3 times positive 3 Plug that in your calculator and you'll get 2.25. And that's our y value of our vertex. Okay? Write an equation of parabola that passes through the point 3 and negative 30 and has x-intercepts at x is equal to at negative 2 and 18. Then find the average rate of change from x is equal to negative 2 to x is equal to 8. So again, they're telling us that we have x-intercepts. So we are going to take those and we are going to say that y is equal to a, again, we're going to take our intercepts here and we're going to take the opposite sign when we're putting it in parentheses. So we're going to say x plus 2 and we're going to say x minus 18. All right? So again, then we're going to take our x value and our y value, and we're going to state that negative 30 is equal to a times 3 plus 2, and then 3 minus 18. So again, negative 30 is equal to a times 5 times negative 15. Negative 15 times 5 is negative 75. So then we're going to divide both sides by negative 75. And that'll give us that our A is equal to 4/10. All right, so our equation then is y equals 4/10 x plus 2 and x minus 18. All right, remember our average rate of change, the formula I told you to, the easiest way to remember it is take the big number. So we're going to take f of 8, and then we're going to subtract our smaller number from it. And again, the bottom is the x's, so x minus, again, a negative 2. So we need to find our f of 8. So our f of 8, we're going to say is 0.4. Again, we're plugging in 8 for x. So we'll get x plus 2. And we'll have 8 minus 18. All right, which is 0.4 times 10 times negative 10, which is negative 40. Okay, we're going to take our f of 2, and our f of 2, we're going to get 0.4, and then we're going to have negative 2 plus 2 times negative 2 minus 18. But what you should notice here is that negative 2 plus 2, this one here becomes a 0, and 0 times anything is 0. So at f of 2, we're going to get 0. All right, so now I'm going to plug it into my formula up above. So I have negative 40 minus 0, and 8 minus a negative is 8 plus 2, which is 10. So negative 40 divided by 10 is negative 4, and that is your rate of change. That would go in that little box there. Okay. Number 9, I suggested to you that you draw pictures based on what you understand. So on the first one, again, we're going to have ones very similar to this on the test. I'm not lying there. So on the first one here, we know that the kicker kicks the football, okay, and it goes, the height increases until it's at 15, all right? So it increases till the height is 15 feet, and it's again 30 yards away. So this right here is 30, this distance from here to here. All right, that's also actually our coordinate for our vertex, right? And then remember, by symmetry, it's going to go down, and again, it's going to be 30 here also, right? So our x values are from 0, 0, and then we have 60, 0 right here. Okay, now remember, and that's for our first one. For our second one, again, if you look at it, this here tells us that one we can write as x minus 0, and then we have x minus 50. So this is telling us we have intercept form. So again, do the same thing. In this case here, we're going to say our intercepts are at 0, 0. And our other one is at 50, 0. And this time here, it's saying that it's going to go, again, we know it's going to be a parabola shape. We don't know what the vertex is. We could find it if we needed to, but we don't have it right now. But do we need it? I don't think so, because what they're asking us is which one travels farther before hitting the ground. So if we look on the first one, it travels 60 yards when it hits the ground. And then on the second one, it travels 50 yards when it hits the ground. So we know that the first one travels farther. And I think it's a drop down and it says first or second. And then you're going to tell me, well, how much did it change? Well, the first one went 60. The other one went 50. So it went 10 yards farther. All right, 10 yards farther. Okay, hopefully that's pretty straightforward for you. Again, write an equation of the parabola shown for the next problem. Right, on this one here, it gives us a vertex. We know our vertex is always h and k, and it gives us 1 point, so we would call that x and y. So again, think, is it vertex standard or intercept form? I just told you it gave us the vertex. Of course, you can see it's not even crossing the x-axis, so there's no x-intercept. So we have to use our vertex form. Again, the formula for our vertex form is y is equal to a times x minus h squared plus k. Again, we're going to plug in what we know. Our y is 4. Our a, that's what we're looking for because we know our x is 0. We know our h is, again, negative 5. Our h is negative 5. But we know a negative times a negative is a positive. And then we'll have plus 1.5, which is our k. So we have 4 here. We know that 5 squared is 25. So we'll have 25a plus 1.5. All right, one person had a problem here, so we're going to subtract 1.5. We're going to subtract 1.5. So then we'll get 25a is equal to 2.5. And to get a by itself, we're going to divide both sides by 25. And we'll get that a, if you work that out, is 2.5 divided by 25, which will be 0.1. So your formula here is now going to be 0.1. I'm going to say x plus 5 squared plus 1.5. All right, don't put y equals y equals. Some of you will do that, I know. Okay. All right, we have one more. So a shopping mall manager creates a parabola to predict the number of shoppers in a mall where X is the number of hours since 8 a.m. and Y is the number of shoppers in the mall. Write a function f that models the number of shoppers in the mall over time, then find the average rate of change in the number of shoppers over the interval in which the number of shoppers is increasing. So round your number on that, round your answer to the nearest whole. All right, so on this one here, again, think, what am I given? I'm given two X-intercepts and a point. So this one here, you would use the intercept form. Always think to yourself, which one can I use? When I use the intercept form, again, our formula is y is equal to a times x minus p and x minus q. So our p here would be 0, our q would be 12, all right? And then our point, our x and y, will be here. So we'll say x and y is there, all right? So I'm going to plug everything in. So 344. Again, our a is what we're always trying to find. Our x is 4, so 4 minus 0. And our x is 4, 4 minus 12. So we'll get 344 is equal to a times 4 times negative 8. So 344 is equal to negative 32a. Divide both sides by negative 32. And we'll get that our a is equal to negative 10.75. So that's what they wanted for our function. So we can say negative 10.75. If you want to write x minus 0, it won't mark you wrong. You can also just put x, and then our next one is x minus 12. So there's your function. All right. Now we are going to look at it for the average rate of change. So to find the average rate of change, first thing we need is our vertex. And if you don't, it should make sense that it should be 6. But if you're not sure, remember, we're going to take our p plus our q, which is 12, and we're going to divide it by 2. So we know that's going to be 6. So we know our axis is symmetry. Again, notice I'm still marking it here since I have it on my paper. All right. I know that x is equal to 6. Now to find my, excuse me, to find my y value, I'm going to plug in f of 6. And f of 6 is again negative 10.75. Again, 6 minus 0, I'm just plugging in the 6. 6 minus 0 is 6. And then 6 minus 12 is negative 6. And when you work that out, you'll get 387. And that should make sense for us because then our vertex here is at 6 and 387. And notice that our 387 is higher than 344. So that's good. All right. And then last thing, again, we're going to take our average rate of change. And then this time they said to do it where it's increasing. So remember, it's only increasing from 0 to 6. And then it's going to be decreasing there. So we're going to say f of 6 minus f of 0. And again, that's going to be over our x's, which are 6 minus 0. All right, so that's going to be 387. minus 0 over 6 minus 0, which if you plug it into your calculator gives you 64.5. But you know you can't have a half a person, so we know that it is going to be 65 because they told us to round up. And then finally, on the very last problem, I told you I didn't do it because you should have put it in your calculator. Again, try it if you didn't do it. So you can get negative 0.98 x squared plus 75.83 x minus 780.68. All right, that's it, ladies and gentlemen. Good luck on your test tomorrow.